Oh, got it. I didn't read that part. I just read R. Lo siento. I'm still trying to do that, but it wouldn't be that. That works, right? I just didn't read the word velocity. Thank you. For the particle described in part B, dy dt is equal to dy d theta. Find the value of dy dt at theta equals pi over 3. Yes, ma'am?
For B, when knocking out, you just said the particle's acceleration is negative.
You could. I'm not sure if there's tons of interpretation with that, but you could. The AP usually likes to use the word decreasing or increasing. So that's why I was trying to put it that way. But acceleration is negative. I guess that would have been all right. Corey? Yes. Not the entire thing, but you would get a point off. Yeah. Well, you can't say decreasing and negative. If you said acceleration is negative, that's okay. If you say decelerating at a negative, you'd be in trouble. Right? If you say decelerating at a negative, you'd be in trouble. Since the rate is. Yeah, I guess you could say that. Okay, so when you guys are trying to get dy dt, which is the same thing as dy d theta, you had to get dy d theta, right? So how are you getting it? So you could have taken the derivative of 3 plus 2 cosine theta times sine theta, right? Because r sine theta. Okay. What happened when you guys went ahead and did product rule? Give me an expression. It's the entire thing? So I don't need a parenthesis. I'm trying to find it such that. When you guys plugged in, you wouldn't need to solve, right? Nope. So you could say dy dt is equal to 3 cosine of pi over 3, 1/2, minus 2 sine squared to be root 3 over 2 squared, plus 2 cosine squared to be 1/2 squared. Right? We have to interpret, so we need to figure out whether it's positive or negative. I'm sorry, I didn't solve it out, but check with Lucy. So when we're solving, just to have an idea, you don't have to actually write down the numeric answer, but I do have 2/4. I do have 2/4, which is 1/2, and I have 3 halves, so that end up being 4 halves, which is 2. Over here, I have 3/4 times 2 would be 3 halves. This is a positive answer, right? Okay. Now here's the dilemma. How am I going to interpret dy dt differently than dr dt? Okay. So I could say the particle is vertically, I'll put Katrina's wording in, accelerating at the rate given above. When theta equals pi over 3. I probably should have put that here. I should put a when and I didn't, and I apologize. Okay. Now here's the struggle. Can you guys go back to part B for a second and explain to me what velocity is decreasing? The what? No. I asked what is decreasing. I know velocity, but what velocity? Because we just said down here, oh, wait a minute, but dy d theta is needed to talk about the vertical acceleration or the vertical velocity. So hold on, what was going on in part B? Not the total pi. The AP will almost always talk about r in terms of distance from the origin, going out from the origin, because it doesn't have to do with horizontal or vertical. It has to do with just going out along the different radii. Now, and the particle is moving with a velocity, yes, and you're not entirely wrong, but I did need you guys, as far as wording, to see the difference between vertical velocity, which would have just been y of theta, right? Horizontal velocity, which would have been x of theta in this example. Vertical acceleration, horizontal acceleration. So then r is not completely separate. Obviously, it's related, but it's not talking about horizontal or vertical. It's talking about how quickly the position is changing from the origin. Does that kind of make sense? Because that's what radius measures, right? So I just wanted to make sure that you guys understood radius. You can think about it as she's alive. Radius, distance from the origin. Is that cool? Okay. With that, section 11.3, if we already graded evens, that was yesterday, right? What were you supposed to work on last night? Catching up / the packet. So the packet, I think I have it up here. There we go. Technically, we should have had an Endeavor quiz today. Sadly, I didn't think about it in time to remind you of it yesterday, even though we talked about it earlier. Why am I bringing this up? Because what do you need to have solid for tomorrow? The forevers endeavors. Now here's a struggle. Can you guys go ahead and turn on your practice test to the one that has to do with an arc length of a polar function, which I believe is number 6. The arc length of a polar function. Do we have, okay, do we have formulas for arc length? Yes or no? Yes. Do we technically have formulas for arc length in polar? No. It was? Cool. What was the formula for it? It's the same, but very different. Okay. It's actually not that different if you think about it. If I can actually get my computer to work. I'm trying real hard. Okay. Because technically the formula would be the following. The arc length from our Endeavor card would be the integral from 0 to pi of 1 plus, x prime. Like parametric, polar and parametric are very similar in how you take derivatives and in how you solve. But why does this intimidate us just a little bit? You have to get x equals r cosine theta and r sine theta. Sorry, you have to get x equals and y equals. Then you have to take the derivative of both with product rules of both. And plug in. Now, could we do that? And the answer is yes. In homework, it lets you take a shortcut. And that same shortcut can also be seen on, let me just do it this way, arc length of polar. I don't think I want that one, but this one works. Okay, do you want to use someone else's work? Okay, what does someone else's work show us? If you were taking this formula, you can use the square root of r squared plus r prime of theta squared instead of doing all the work of who is x, who is y, who are each of their product rules. Let's FOIL everything out and square it all and simplify with trig identities. Could you do that? Yeah. Do you want to? I don't think so. So therefore, what would the correct answer be? I apologize, Corey, for yesterday. The correct answer is A. Thank you. The correct answer is A. Now, with that, could that possibly be a good formula that we add into our endeavors? Not a bad idea. Now, we were talking about vector calculus. That's not where I was looking. Arc length was a long time ago, wasn't it? Okay. So let's come back here. And we'll do endeavor number 35 to be arc length of polar curves. P.S. What was I trying to tell you guys? It's probably a good idea to study these formulas for tomorrow, yeah? Yeah. And just a quick hint. That was really random, Katrina. I could do x1 to x2, right? Except, no. What's this in terms of? Good. Theta 1 to theta 2. Square root of r squared plus r prime of theta or dr d theta squared. Will that make our lives a bit easier if they ever ask us for it? Perfect. Okay, are there any other formulas we should probably know for the test tomorrow? Yeah, the vector formulas having to do with vector calculus, having to do with the magnitude of speed, magnitude of acceleration. Do we need to maybe know the power reducing formulas? Because I might make you do it by hand.
Yes.
Yeah. How important is polar area and area between polar curves?
Can you teach us how to find the bound?
Hey kiddos. Thank you. We do not usually yell across the room, or at least we should not yell across the room. So let's go ahead and try to act like the age that we pretend that we are. Or we should be, maybe I should say instead. So we have our Endeavor cards now up to date. Quick heads up. There will be, in some way, shape, or form, a testing of the endeavors tomorrow. Could be on a bonus. It could be like a quick little half sheet before you start the test, and then you go back and look at your endeavors again and make sure you have it. But there will be some sort of testing, quizzing of the endeavors tomorrow. We tracking? Because we didn't do it today. But we have this new endeavor now. It's good to go. So for those of you guys that did start the review, I'm thinking that's why you're talking nonstop. I'm hoping that's why it is. I'm hoping it's productive. So let's go ahead and go to the practice test because you were supposed to work on it last night. And my question is, first of all, maybe we should grade multiple choice answers. For those of you guys that have them done, let's go through quickly. I did it this morning real fast while I was on duty and then for the 5 minutes that we started class. What did you guys get for number 1, those of you that did it? I agree. How about number 2? I agree. C as in Cadillac. There you go. You're welcome. Number 3. A. Number 4. C. Number 5. B. Number 6. A. Number 7. I got D. D as in Delta. But we can say doggo too. Because remember, they gave you an x of t and a y of t. Didn't we have to do y prime over x prime and then take the derivative all over x prime again? Right? It's parametric. Number 8. A. So now as you get down into the long answer, I haven't done them. Have you guys gotten stuck anywhere or have any questions? P.S. I will scan my key and I will put it on your shared drive, but for right now I do not have 9, 10, 11, or 12 done, but I'm willing to look at some. And if you guys don't have any questions, we'll just work for the end of class. But any questions that we have on 9, 10, 11, or 12? Yeah. 11. D? Okay. If you guys haven't looked at 11 yet, you might want to look at it now. I have initial velocity. I have how high the cliff is. Launched at an angle of 30 degrees. I have a horizontal wind blowing against. Thank you. Okay, let me go ahead and get a quick picture of it. Jason, are you giving input as to the problem? Perfect. So why don't you say it out loud? Go. Yes, but you can just say for the entire problem. Whatever you're telling Noah, let me hear it. Okay. Using symmetry. And then take. Are you doing time or are you doing height? I'm solving for time so that I can plug in for height. But if it's hitting the ground? Yeah. Oh, because the height was 384? Yeah. So you know that 192 is perfectly halfway. Yeah. Got it. Right, for the original. Speaking of position, isn't that what A stands for? So, or A was asking? So the rest of you guys, how would we get the situation in the path of the projectile? What are they asking? Mm-hmm. Good. How would you do the velocity vector for going forward? Because launched at, right? So we could say that the velocity of the launch, you want to do it that way? How do you do that? Oh, so you didn't put it in vectors though? Okay. But then eventually, wouldn't it be helpful to do cosine of 30 and sine of 30? Okay. So I was just kind of setting up the entire situation. Sorry. I was just doing all the background work. Because you guys started talking about velocities. We already have the path of the projectile. It's right there, right? So this might be now going into B a bit as far as vector equations. However, this is just what it was launched at. What else do we have to take into consideration? Okay, so that'd be like the wind. Was it wind? Okay. Which means we can just put 0 for vertical, right? Does that make sense? And then we could say, you do it either way. You could do 18 like cosine of 180 if you want, because then it's coming the opposite direction. Or you could just do negative 18. That works also. And we could do acceleration due to gravity. Is that what you guys are thinking of? Just negative 32 feet per second squared? Okay. Letter B then. How? Yeah, I mean, it's technically we learned in CalcBC too, right? You could do 1/2 acceleration t squared, right? Plus. Yeah, we could do it that way. Then we could go ahead and plug and chug, right? What will we plug and chug for the initial velocity? Why have I left that blank? Can I just plug in my initial 128 cosine of 30? Mm-hmm. For the horizontal, not for the vertical, right? So we could go ahead and find the magnitude of the velocity vector. Hold on, but who's my velocity vector? So we wouldn't have to put them together? Okay. So we could go ahead and just do a quick little vector sum. And so we'd have 128 cosine of 30 minus 18. Careful, the 30 is just there, right? And then we'd have our 128 sine of 30. There we go. Then we can find the magnitude of that velocity, true? Because you're launching, but the wind is pushing against you. And so you're launching, this is your horizontal launch speed, but you have to subtract the negative 18. Sorry, subtract the 18. Because the wind is pushing against, like, as soon as you launch. I apologize. I said minus and negative, but I didn't mean it that way. We're actually combining the two together, and when we combine, we need to go ahead and take 18 away, because it's pushing, whereas the wind is pushing. Okay. You can solve for the magnitude, right? Letter C. What was going on as far as the maximum height? Square root of speed is the magnitude of velocity, which would just be b squared plus a squared, or a squared plus b squared. Yeah. If you're doing like the magnitude of acceleration, you have to do like the derivative of both in the square root squared. Maximum height, what are we doing? Yeah. You could basically just take the derivative and set y equal to 0 because you're max, right? It'd be a horizontal tangent, which would be the same thing as y prime over x prime if we did parametrically define this, but we didn't actually parametrically define it, did we? We just kind of parametrically showed the vectors. So we just went straight to the path. So then setting y prime equal to 0. Hold on, I don't like the of t. Because we're technically the path of the projectile. The path would technically be in terms of x, not in terms of t. Oh, using t in seconds as the parameter. Okay, I was making sure. Sorry. I was making sure. So then y prime of t equal to 0. Basically, long story short, Jason, what'd you find out for that? Oh. You guys can just graph it, right, technically? The new equation. Oh, use a different one? 3.524 was your old value, or is the new value? Okay. Someone can double check Kyle. 524? Is this in seconds?
Yes.
Yeah. What is this maximum height you have to plug in, right? I'll just call that A. Yeah, bud. It wouldn't be quite as physicsy. They wouldn't probably give you the angle. They would probably give you a vector equation or a velocity vector, and you would just work with it. So you'd have similar things like maybe having to use the magnitude, but you wouldn't have to come up with this formula for the path. They would somehow give you probably defined parametrically, and then maybe you would get the path by eliminating the parameter. That's possible. I mean, maximum height, they could definitely ask you to do that. How far horizontally, but it wouldn't be quite as physicsy. Has anybody backed up Kyle with a 3.524? Okay. You got it? Corey got it. And then the height that you got from that one? The dilemma with that, Jason, is it's not going to be halfway. Yeah. So then letter D, which is, I think, Kyle, your original question, right? How far horizontally does the projectile travel before landing on the ground? Can't we just set y of t equal to 0? Now we'll find the time, but what are they actually asking for? The horizontal distance. I mean, from the equation it'd be. Yeah. Yeah. Okay, then t equals. See if anyone backs them up. What's the dilemma? What have we not actually written down anywhere up here? The horizontal. But what do we have up here? Don't we have an expression for the horizontal component of the velocity vector? So if this is how fast it's going in feet per second horizontally, what can I do now that I know the time that it's traveled? Well, it's that many feet per second. So can't I just multiply by seconds? Distance equals rate times time. So I can say the horizontal distance is going to end up equaling my 128 cosine of 30 minus 18. Oh, you didn't get? Using that equation? That would make a little more sense. If it takes 4 seconds to reach the maximum, I would assume it would take a while to... No, you're okay. So what'd you get, Noah? Kiddos, long story short, number 11. That's probably the strangest one in that that's the most physicsy one. It's going to be more physicsy than it will be. So I'm glad we went over it today. That way you guys didn't see it tonight and you're like, well, especially my non-physics people. But nothing like that is going to, at least not to that extent, will be present tomorrow. Instead, I would focus on what looks more familiar, like 9 and 10 and 12. Would it be a good idea to go back to homework problems and make sure that you understand 11.1, 11.2, 11.3? Yes. Are there problems in the review that you could play with? Definitely. However, I would definitely make sure that you understand the multiple choice. I will scan this when it's up, but I'm not going to scan number 11. I'm not going to do that one again. Because as I said before, for the AP and for me tomorrow, let's look at 9 and 10 and 12. Jason.
Because the only one that says allow your calculator is number 12.
Well, could have. I was just letting you guys use a calculator for sake of time. But, I mean, it's unit circle, so it wouldn't have been a big deal. Could have used quadratic formula. Not that you would have wanted to. You could have. You could have. And you could have just plugged it in and left it unsimplified. You know what I mean?
Integrated that to get x and y's, and then from there you set my y's equal to 0, or this, my velocity to 0. That's all the times equal to 2, and then re-plug it into the position one to get the position.
For letter D?
Oh no,
Because you're setting.
I was still doing, I think it's C, because I got times equal to 2. Because I haven't corrected all the words. So B is still incorrect. This is all been corrected.
Why would that have been negative 32? Oh, because you're subtracting gravity.
Wait, is it a sea bear or a bearfish? Sea bear. Sea bear.
I didn't know, right? Why can't we have this on? Yeah, why can't we have this on? Oh, we'll have it on physics, but we don't have it.
I was right. I just didn't word it well enough for you guys to understand. I didn't like how we were using the horizontal vertical for that initial magnitude. Yeah, I agree. We shouldn't have used magnitude for horizontal vertical. See, I was asking that, and then you guys didn't realize what I meant with the y and the x's. Right? Because technically this is only patterning the vertical motion. True? So if it's only patterning the vertical, we should have only used the 128 sine of 30. Then it would match up with yours.
Okay. So it makes more sense now.
Yeah.
Okay. It makes a lot more sense if you're doing it. So these are y.
Right? That makes more sense. See, I paused there. I was like, y and x's. Wait, we're only doing y's, and then I just kept moving. Well, it's okay, though, because it would be fine.
Yeah, we get the general idea.
We took a magnitude considering horizontal and vertical. We should have only considered vertical because it was only vertically, we were only making an equation for the vertical component. So we shouldn't have put horizontal and vertical magnitude. No, but it's asking for the path in terms of y. We have to deal with the horizontal eventually, but we weren't supposed to deal with horizontal first. It should be. Definitely during lunch and definitely after school. Definitely during lunch and, definitely 7th period.